Hello, everyone, and welcome to the 2024-2025 season of online viewing sessions hosted by the Kalamazoo Astronomical Society. It is great to see you all here tonight. It looks like we could have a full house here on Zoom tonight. We're currently clocking in at roughly 83 people or so, with more coming all the time. And we even have a handful of people joining us live on YouTube. Of course, not quite live because they're like 30 seconds behind us. There's a bit of a lag in there that we can't prevent. So it is great to have you all here, and it is a great night in Michigan to have an online viewing session because it is very cold and very cloudy out there. So no astronomy for us outside live tonight. So we're very glad the skies are mostly clear at Arizona Sky Village. So without further ado, I'll unmute you here shortly so you can chime in, but allow me to give you a little intro of the online viewing sessions and where the telescope is located. So let me go back to sharing the screen here. All right, so here's our title slide for the evening. And of course, you can see a house and observatory here. This is the house of KAS member Mike Patton. And this is his observatory called Piishi Observatory, which we'll see more later. And if you've been attending online viewing sessions for a while, this is actually our sixth season. I usually cycle through like four of these images, like the same four over and over again. But I asked Mike to maybe snap a few new ones, and so this is a new one. I haven't showed this particular image yet, so this is a drone view of his house and an observatory where the telescope is located. So more specifically, um, the observatory is located near a very small village called Portal, Arizona. And as you can see from the star here, it's kind of in the southeast part of Arizona, not quite at the tip of the state as I sometimes describe it as, but it's pretty much in the southeast part of the state, right on the border with New Mexico. And Portal is a very small town. I even stress that's a bit of an exaggeration. So real quick here, let me give you a tour of downtown Portal for those of you joining us for the first time. So here's the post office in downtown Portal, Arizona, and you can see the zip code is 85632. So everyone can go there to drop off packages. They do have mail delivery service at Arizona Sky Village. And then very nearby is the Portal Store Cafe and Lounge. And as you can see from the sign here, I probably took this back in 2017, I think. They do feature live music from time to time, and we did eat there a couple times, and they have pretty decent food. So that's the Portal Store and Lounge. And that concludes our tour of the main stops at Portal. So yeah, that's it. So as you can see, it's a very small place and it's very dark. Just west of Arizona Sky Village here is the Coronado National Forest, which is 1.78 million acres in size, and you can't develop national forest land. So the skies around Arizona Sky Village should stay dark for quite some time. And yes, it is indeed dark. On the Bortle scale, which is what we use to measure, the amount of light pollution or lack thereof, it's kind of an upper level 2 on the Bortle scale, just short of a perfect dark sky site, which is 1. You can see there are some really black areas here that do qualify for Bortle 1. But we're right where the X is here. And, so we're not kind of the light gray, we're kind of the darker gray. So it is pretty dark there. And we'll give you a sense of that here shortly. Although it's not quite fully dark there yet, but it should be pretty soon if it's not already. So here's another view of the observatory, and it is called Piishi Observatory. That is Apache for Nighthawk. Mike Patton, who owns the observatory, he wanted to keep a bird theme like we have here in Kalamazoo. So many of you know we have Owl Observatory at the Kalamazoo Nature Center, where we have our Leonard James Ashby telescope that we use for our public observing sessions during the more summer-like season, not now, obviously. And so that's why he wanted to call it instead of Nighthawk, he wanted to go with the local culture and called it Piishi Observatory. So it's a 20 by 20 roll-off roof observatory, just like Owl Observatory, just it's bigger. Owl Observatory is only 12 by 12, so this one's 20 by 20. And you can just see the remote telescope poking up here. That's the 20-inch, and this is the Takahashi here. And in this part of the observatory, we have the warm room or the cool room, depending on what time of year it is. And you can see we have our uh, weather uh, station here. That we have the wind measuring device. I always forget what these things are called. So if you know what these things are called, you can put it in the chat and maybe I'll remember one day. And then this little box here, that is our all sky camera. So the really cool thing about the all sky camera now is we've just recently upgraded it. Uh, if you've attended online viewing sessions before, you know we had an S-Big camera, which had a small CCD chip, very low resolution, but we have since upgraded. This is technically the old all-sky camera, the old S-Big camera, but the housing for the new camera is pretty much identical, but one of these days we'll get an upgraded picture here. So the new camera is much better. We now use a ZWO ASI 183 MC camera. It's a pretty good size chip, so it gives a really big image compared to the old camera. And the ZWO cameras, they always come with a little cheesy fisheye lens that you could use, but we wanted to get something a little better quality, so we use a Fujinon 2.7 millimeter f1.8 fisheye lens. And of course, it's hard to get a good view of it inside the housing, but this is what it looks like inside the housing when one of our members, Jim Kurtz, put that together for us. And we use a program called AllSky, ALLSKEYE, All Sky, and that's what we use to control the camera. So let me switch to the All Sky camera here real quick. I'm going to go back to my browser, make sure it's open there for me. There we go. It's open. And so I'm going to share a different screen here. And there we go. So there is the new all sky camera. And this image is greatly reduced. We could make it much bigger, but the focus still needs to be tweaked a little bit. And we need to raise the camera just a tad, because we have problems using this during the day, because we do use it during the day, mainly for weather monitoring and that sort of thing. But this camera is far better than the old camera. So let's go ahead and take a quick tour of the night sky as seen from Arizona Sky Village. To get your directions oriented, you can see our little compass here. Special thanks to Pete Mumbauer, who's here with us, that helped me figure out how to put this thing in there. So you can see north is basically right at the top, and you can see we have the page reload every so often, so we get a fresh image. It's taking images every 2 minutes or so. We should probably scale that back to 4, though, as we used to do. So you can see east and west are flipped. So east is over here. There's a little bit of a light dome here, but it's really exaggerated because this is like an 80-second exposure. And you can see some stuff over here. We'll talk about that shortly. And so obviously south is at the bottom. And you can see the date and time of the image here. And of course, you can always go to this webpage. You can go to our website, kasonline.org, go to Remote Telescope. Of course, you can learn more about the remote telescope itself, and you can pull up the Piishi All Sky camera, and I won't do that because that's where we are now. So there we go. So it may be late November. We're kind of getting into mid the late fall, but we still have the stars of the summer triangle. So here's the summer triangle. We have Vega, Deneb, and Altair. So Vega, Deneb, and Altair are the three stars of the summer triangle. And the summer triangle, obviously, is an asterism. The three constellations are Lyra. So Vega is at one corner of a little isosceles triangle. You can just see it here. And then there's a parallelogram. So Lyra has some cool stuff in it, but it's a pretty tiny constellation. And then from Vega, we go over to Deneb, which is the tail of Cygnus the Swan, but it's also the top of another asterism called the Northern Cross. And we can go from Deneb to Satyr to Albirio for, kind of the vertical part of the cross. And then we have, hang on, there we go. There goes like a plane probably. Could be a satellite, probably a satellite. And so then we have two stars on either side of Satyr there that form the cross. And that's the bulk of Cygnus, but Cygnus goes a little further to these little three stars here for the wingtips. And then there's an extra star out here for the wing. And then there are stars that kind of curve out and back for the neck and the head here with Albirio, a very pretty double star that we often show during the summer. And then the last star, again, is Altair, and this is the head of Aquila the Eagle, which has another triangle around it. And this is the body, this little triangle there. And then there's a very straight wing here, then kind of a swept back wing here, and then two little stars for the tail feathers out there. So, like the swan's kind of flying toward the west, and the eagle's kind of flying toward the east. And then, now that we're in fall, we can go over to the Great Square of Pegasus here, which gives us a hint to the next constellation. But the Great Square, as it's known informally, is another asterism, kind of the dominant asterism of fall, while the summer triangle is the dominant asterism of summer. And these three stars form Pegasus. This is the back of the horse. So there's kind of like an invisible wing going out there, because obviously Pegasus is the winged horse in Greek mythology. And then this is kind of his front, and he's upside down in the sky for some reason. This is his head. And then he has like a leg kind of going off here and a leg kind of going off here. But then this star in the Great Square, this is Alpheratz, which is the head of Andromeda. And Andromeda is basically two arcs of stars. There's kind of an arc here, an arc up above, which is a bit fainter. And later on, we'll look at this little smudge right there. If you don't know what it is, well, we'll keep you in suspense about what this little tiny smudge above the star is right there. We'll check that out later. That's one of our regular highlights here at our online viewing sessions. And there's quite a few other constellations that we could point out, but we'll notice over here we have Venus, which is very bright. Over here, I believe we have Jupiter rising. This is Aldebaran and the V-shaped Hyades cluster. And this is the Pleiades. We always check out the Pleiades, but we're going to save that more than likely next month. And we do even have the stars of Cassiopeia here. Cepheus is here somewhere, but boy, there are so many stars. I can't find it. It's around here somewhere, but it's getting pretty washed out in stars in the Milky Way. And we can note Perseus right there as well. And kind of on the horizon, you can see this funky thing here. You're probably wondering what that might be. This is just our bird perch. If you go to the our Facebook page, I just posted a image there earlier of two birds on the perch. Usually we just see one, but today there were two there. So we put this bird perch in because obviously the birds want to land on the highest feature they can find. So they kept landing on the dome of our all sky camera, and they kept leaving little surprises behind, so to help minimize that, we put this bird perch here, and it works like a charm. We rarely ever get the old bird poop on the dome anymore. And up here is Mike Patton's house. that you've seen earlier in our title slide. This is the roof of the observatory. It's a little bright. We need to look into why it's so bright there. It shouldn't be so bright. Oh, it reloaded again. And this is Mike's newest neighbor. If you attended the session about this time last year, you heard me just rail and rail on this guy because he had some bright light shining out this window, and it was just driving us crazy. Well, at least it was driving me crazy. But now he's been well trained, and he no longer seems to have his bright light shining out of his window all the time. And then one thing I want to ask Mike if he's attending, he can tell us later when I unmute everybody, but we don't know what this thing is up here. I'm not sure what that is up here. Because the old Sky camera, it cut off the north and the south, so I've never really seen this before, so I don't know what that is. Oh, and way off in the distance, I'm pretty sure Mike can correct me later, but I believe this is the house of one of his other neighbors, Rick Benno. And we like to mention Rick because he's been really helpful with our remote telescope. He built the bird perch, he built the holder for the all sky camera, so and much more. So he's been a great help to us. So we'll check back on the all sky camera here from time to time. Okay, so we should be back here. All right, so our first telescope we're going to use tonight is our Takahashi FSQ 106 EDX3. And we just recently, toward the end of last summer, we had the Takahashi collimated. It's still not 100% perfect, but it's a lot better than it used to be. So the star images are much better quality than we've had in the past. So basically, the Takahashi, I won't go into great detail here. You can kind of skim through this real quick if you want, but it's basically a 4-inch refractor. So, you know, there's a series of lenses up front, and we replaced the stock focuser with a very nice Moonlight Nightcrawler 2 that can support the massive weight of our imaging camera there. And so the Takahashi rides on top of the plane wave telescope. And then, of course, the camera itself is an SBIG STX 16803 CCD camera, which are becoming a rarity because CMOS cameras are rapidly taking over from CCDs. I don't think really anyone sells a serious CCD camera anymore. And we are looking to switch over to CMOS here sometime, hopefully in the next few months or so. So if you are possibly interested in this camera or the other identical version of this camera on the other telescope, they will soon be put up for sale. We don't quite have a price yet, but you know, we'll work something out. So these are both full frame CCD cameras. In fact, they're even more full frame than your typical full frame because most full frame cameras that you get from like ZWO or whatever, they're like 36 by 24, but these are massive, like nearly 37 millimeter square chips. So they are big chips, a lot bigger than your standard variety CMOS camera. And they are both attached to filter wheels that hold a total of 7 filters, and we have each filter slot, you know, filled. All right, so let me go back to my web browser here. There we go. So we're back to the All Sky camera, and let me just give you a live view from inside the observatory. So here it is. This is Mike Patton's FOSS cam. We did have our own webcam. It's still operational, mounted on the wall over here that you could view on our website, but I could not get the live stream on the webcam to work on our website anymore. So I just took it down. The camera itself still functions, but we just use it to check stuff if, you know, if the roof doesn't roll back on or something like that. But usually the FOSS cam is all we need to monitor things there. So this is the remote telescope live. This is not a still image. See, look, I can even turn the camera. See, there it goes. And so we'll talk about the 20-inch later, but right now, obviously, we're using the Takahashi because the flip flat is open. So you can see there's a little cover here that goes over the Takahashi when it's not in use. Planewave now has something for the big scope, but it costs $5,800. So maybe we'll do another fundraiser for that because it would be nice to keep the primary covered up when we don't use it. And you can see there are other telescopes in the observatory. They all belong to Mike Patton. So he has two plane wave mounts in there. These are both L350 plane wave mounts. If they really had these when we first started the project, we probably would have got one of these. He used to have a big 7-inch refractor on here, but he says it didn't work very well in the winds they have out there. So now he has an ASCAR 120 millimeter, which I'm sure is very steady on this mount. And we can turn a little bit this way. And you can see the other plane wave mount, and he has a 14-inch Schmidt-Cassegrain on there with a Hyperstar setup. And there's another telescope just beyond this one that you can't see, and that's his Coronado solar telescope. So every spot in the observatory is filled. And so this is the door that takes you to the warm room. And this is our flat field screen for the 20-inch. The Takahashi flip flat here has its own flat screen. And you can see it is, in fact, our part of the observatory because there's our logo. There it is right there. So that is our little corner in Piishi Observatory. All right, so let's go back to the PowerPoint here. And our very first target of the night is something a little bit special. This will be the first and probably only time we will ever image this during an online viewing session. So I hope all of you have had the chance to see Comet C2023A3 Chūchūnshāng Atlas. So of course this comet put on a great show in mid-October for at least those of us in the northern hemisphere. Those in the southern hemisphere got two peaks of it, both in the morning and the evening sky. I guess we could see it in the morning sky as well, but not very well. So the right ascension declination is for about 10 minutes ago. So it hasn't moved that much, but I had the coordinates set for about 6:45 Mountain Standard Time. And the magnitude estimate here comes from Starry Night. It could be a little bit brighter than this, a little bit fainter, but that's probably reasonably accurate, about 8th magnitude now. And of course, it's really receded from the sun. It's not nearly as big as it was earlier. So now it's about 1.75 astronomical units away. And of course, one astronomical unit is the distance between Earth and the sun, about 93 million miles or 150 million kilometers. So if you really didn't know much about this comet, if you didn't see it or just barely saw it and don't know anything about it, it was discovered by the Purple Mountain Observatory in China on January 9th, 2023. And while it was awaiting confirmation, it was removed around January 30th because there were no follow-up observations from the observatory here. So that's why Purple Mountain Observatory doesn't get sole credit for it. And in Chinese, apparently a bad translation of Mandarin Chinese, Purple Mountain translates to Chūchūnshāng, the first name of the comet. Now, the other half, Atlas, that stands for the Asteroid Terrestrial Impact Last Alert System in South Africa. They look for, potentially hazardous asteroids. And they discovered it from their Sutherland site or Sutherland Observatory, probably in one of the smaller domes here, on February 22nd, 2023. And it definitely wasn't discovered in this observatory. This is SALT, the South African Large Telescope. This is the identical twin of the Hobby Eberly Telescope in West Texas. If you've ever been to the Texas Star Party and took a trip to McDonald Observatory, you no doubt saw the twin of this telescope here. It's nearly 10 meters, so a little big for comet hunting. So this is where the comet currently is. You can see Altair in Aquila that we mentioned earlier. And this star right here is Theta Serpentis, or Theta Serpens, or also known as Alya. And yesterday, the comet was like right next to the star. And so tonight, you can just kind of see it as this little smudge here. It is right above it. So before I go on here, let me go back to the browser. I can figure out which one it is. There we go. And click on that. I'm going to close my email. Oh, and someone has their headlights on. Oh, that's just awful. And I got to get the zoom controls out of the way. There we go. So this is ACP, the Astronomer's Control Panel, which is what we use to control the telescope remotely. And I already have the coordinates all set up. And we're going to do a 2-minute exposure with the luminance filter. And I'm going to hit acquire image. And it's going to begin to take its image. So let me go over here. I'll turn off the infrared light here in just a second. But we should see the telescope just slew a little lower because it's pointed in the right direction. It's just pointed too high. But in just a second or two here, you'll get to see it actually move someday. While we're waiting, there it goes. So I believe the comet is about 30 degrees high right now. So it's not really low. And it's pretty clear. You can't tell now, but there we go. Let me turn the camera off because that could cause problems in the image. And it's going to do a 20-minute plate solve. It'll just take a quick 20-second exposure to figure out exactly where it's pointed. And it should reasonably center the coordinates I have. It probably won't be perfectly centered because the coordinates I use probably aren't an exact match of where the comet is. But the Takahashi has a pretty wide field of view. So it should be somewhere within the field of view of the camera. So while we're waiting, let me go back to Zoom here. And I will allow everyone to unmute themselves. There we go. Okay. So it's going to try to do another 20-second image. Sometimes it seems like the plate solving with the talk hasn't been, it hasn't been functioning as well lately. I don't know what's going on with that, but who knows. So it's going to do another 20-second plate solve image. And then it'll look for a guide star, even though we don't really need it to guide during the 2-minute exposure. But, remember this telescope is controlled remotely. So all that stuff is kind of built into the routine here. I can go into the program and turn all this stuff off, but I'll forget to turn it back on. Then when we do need guiding later, then we won't have it. So it's best that I keep it on. So the telescope is slewing a bit. Again, it's centering the target. You can see all the lights of the telescope there, or and around the telescope. But we're not going to turn the infrared camera back on. And it says aiming failed, but trust me, it's probably going to be on the chip. I'm pretty certain. I do have a backup image from last night. Some of you may have seen it on our Facebook page. So if you're curious, you can go find that now. But maybe I'll show it to you later if this doesn't work out. But it should. We shouldn't have any problems here. So while we're waiting, let me go back and finish my spiel here. So the designation of the comet, it's C 2023A3. So the C indicates that it's a non-periodic comet with an orbital period longer than 200 years. And with this comet, it is way longer than 200 years. And so, a lot of people in the media were saying this comet visits us every 72,000 years, or it'll be 72,000 years before we see the comet again, or some crazy figure like that. But odds are, because the eccentricity of this comet, the shape of its orbit is nearly 1, which means if it were 1 or greater, it's an open orbit, which means it'll slingshot around the sun and never come back. But this comet didn't come really close to the sun, which is why it didn't get as bright as like Hale-Bopp or something like that. So it's nearly 1, so odds are this comet is never going to come back. And then the A3 denotes that it was the 3rd comet discovered in basically January, February 2023. So that's kind of what the designation of the comet entails. And so this comet comes to us from the Oort cloud. So this is the orbit of Neptune here, the outermost orbit in the solar system, for the 8 major planets. Sorry, Pluto fans, but it's not a planet. Get over it. And just beyond Neptune, a little over 30 AU from the sun, is the Kuiper Belt. And as the Kuiper Belt's name implies, it's pretty flat. It's pretty much in plane, the same plane as the planets orbit the sun, but it's actually not a Kuiper Belt. It's more like a Kuiper torus. It's like donut shaped around the sun. So it's not flat. It's more like a donut. So objects within the Kuiper Belt are usually within 30 degrees of the ecliptic, which is the name for Earth's orbit around the sun. And so Pluto is in the Kuiper Belt, and many other familiar objects in that region are in the Kuiper Belt. And it goes out to maybe from 30 to roughly 50 AU, probably a bit longer than that, probably between 30 and 100 AU. But zooming out to 10,000 AU is the Oort cloud. So yes, the Kuiper Belt, plus all the solar system is in this little tiny square. And so the Oort cloud is extensive. It is a sphere, or cloud as we call it, that surrounds the solar system. And so pretty much Kuiper Belt objects account for the short period comets, like Halley's Comet, that orbit in a period less than 200 years. But Oort cloud comets, they have much greater inclinations. They have much greater tilts in their orbits, and their periods are usually much, much greater than 200 years. And so that's where Chouchen-Chang Atlas comes from, the Oort cloud. It's probably been on its way to the inner solar system for millions of years. All right, so let's see how we're doing here. Let's go back to the browser. Oh, looks like we're all done. Okay, so now, if you've ever attended online viewing sessions before, when I unveil the image, I always prefer people unmute themselves so I can hear your natural reaction to see the images. So is everyone ready to see the first image of the night?
Yes.
Yes.
All right, here we go.
Woo.
Oh, wow.
Yeah.
Those.
Wow.
Oh, wow.
Wow.
Wow, cool.
Nice.
Real cool.
Very impressive. He's going to tell us.
Real cool.
So yes, this is live. This is quote live from the telescope. Now I took 3 images yesterday, and they all had satellite trails in them, and this one is no exception because there is so much space junk up there today. You can't get away from the satellites, especially in a wide field of view like the Takahashi. So we have 1, 2, probably 3. This could be a much fainter one. Looks like it may have been tumbling because it gets bright, and it gets dim, and it gets bright, and it gets kind of dim, then it gets lost in the Milky Way here. So yes, here's the comet. You can see it's gotten quite a bit fainter, a lot smaller. And here is Alya right there, Theta Serpentis. And then we have the star clouds of the Milky Way, because the comet is really close to the disk of our galaxy right now. And don't forget, Sometime, hopefully tomorrow, but maybe Monday, you'll be able to download all the images that we've taken tonight. If you are a KAS member, or if you are on the online viewing session email list right now, you already have the link, but we'll put it in the chat later and you can copy it and save it and use it for later. And we'll tell you how you can become not just a member, but or just join the online viewing session email list. So this little comet here, Chouchin-Shong Atlas, it actually passed perihelion. It's closest to the sun at a distance of 0.39 AU. That's roughly the same distance that Mercury is from the sun on September 27th, 2024. And it reached its brightest magnitude shortly after passing the sun on October 9th with a magnitude of minus 4.9, which is bright or brighter than Venus, but nobody saw it because it was right next to the sun in the sky. It made its closest approach to Earth on October 12th at a distance of 0.47 AU, which is 44 million miles or 71 million kilometers. And as many comets from the Oort cloud do, this has a retrograde orbit, and it has an inclination of 139 degrees, which clearly tells you this thing comes from the Oort cloud. And the nucleus, the actual dirty snowball, it's difficult to estimate the size, but some estimates say it's about 2 miles or 3.2 kilometers in diameter, but it could be smaller. It's very likely smaller. So there we go. And I'm glad it wasn't centered, because that gives us this nice view of the Milky Way here with the Takahashi. So any questions about the comet or the image before we move on? All right, so we'll go ahead and close that up for now. And I'm going to go to the next target here. So I'm going to scroll down, and I'm going to type in IC 1396. Make sure I hit get coordinates, because that would be bad. I'm going to switch to the hydrogen alpha filter, and this is going to be our long one of the night. We're going to do a 10-minute exposure of this one, and hit acquire image.
Okay,
All right, let's go back to the telescope here real quick. There it is. So yeah, we have to turn off this infrared light because it would really probably wreak havoc on some of the images. I was hoping to catch the thing slew, but there it goes. Okay. It takes a second to get it going. So we're going to look pretty high in the north there. So we'll just go ahead and let it slew there. And then we will introduce you to our next target. Okay. So yes, indeed, our next target is IC 1396, the Elephant Trunk Nebula. So this is its right ascension declination. Its magnitude is very deceiving. It is very difficult to observe visually, even though it's 5.6 is pretty bright for visual magnitude, but it's big. So its surface brightness is very low. It's roughly 3 by 2.5 degrees in size. So just for reference, to make this mean something, the moon, the full moon, is 30 arc minutes. So this is 170 by 140 arc minutes. So in our sky, this region is very large. And it's pretty big too. Even though it's 2,400 light years away, it's far bigger than the Orion Nebula, which, it's a little closer, but this nebula is much bigger. So here's this general location. Hang on just a second here. I'm going to mute everyone because someone has a really annoying noise in the background there. So you can unmute yourself if you don't have any annoying background noises. So here's its general location in the constellation Cepheus. I did point out Cassiopeia later, but notice I mentioned I could not point out Cepheus because it gets lost in the stars in the Milky Way on our all-sky camera. But this is its general position in the sky. This is generated with Starry Night. And this image is from Sky and Telescope's Pocket Sky Atlas that I kind of scanned and, quote, borrowed. So this is the bottom of Cepheus that we saw here. And then so here is this very large region. So this is definitely a job for the Takahashi. The 20-inch would show us a very tiny portion of this nebula. So it's located about 1.5 degrees southwest of Mu Cephei, which is right there. This is a very popular star called Herschel's Garnet Star. It's one of the reddest stars known, but usually when you look at it, it's kind of a very orangey color. It depends on what brightness it's at because it varies in brightness. When it is dimmer, it can get pretty red. But through big telescopes that gather a lot of light, it tends to look a little more orangey. But garnet's a pretty good designation for it. And so the SIMBAD database lists IC 1396 as an open cluster because we can see the little dots with yellow inside denote open clusters. So there is an open cluster in this nebula. And the cluster itself is about 3 to 4 million years old, which for stars is pretty young. And the cluster itself is also designated as Trumpler 37. And Trumpler is a catalog of 37 open clusters. So this is the last entry in the Trumpler catalog. And it was compiled by the Swiss American astronomer Robert Trumpler in the early 20th century. So IC 1396 is one of the larger emission nebulae, as I mentioned, taking up about 3 degrees of the sky at its largest. And so the elephant trunk itself is actually a dense globule inside the nebula. And that's designated as IC 1396A. So Mu Cephei here is another, as I mentioned, is a very interesting target on its own. It appears, again, on the edge of the nebula, as you can get a sense of on the chart here. And it's about 2,840 light years away. And it is one of the reddest stars in the sky. And it is a luminous red supergiant, possibly a hypergiant, which is even, obviously bigger than a supergiant. And it's one of the largest stars known. It is between 1,260 to 1,650 times the diameter of the sun in true physical size. So Herschel's Garnet Star, it's only faint and small because it's really far away. It's actually an incredibly large star. Okay, so this means we're going to go back to ACP. Here we go. And let's see how we're doing. So we've already started our exposure. And, it takes time. Oh, no, I'm fine. I thought I forgot to do something, but that comes later. So, we didn't get a guide star. Well, we'll see how we can do. I'm surprised it didn't find a guide star. There are plenty of stars that it imaged to guide, but it just didn't pick one. Well, darn it. Sometimes it does, sometimes it doesn't. That's why we're going to try another guiding method here in the future, because our current method of guiding through the 20-inch just isn't cutting it. So we're going to try something else here in the near future. But we'll see. It'll probably be a little on the trailed side. But, oh well, that's the best we can do, I guess. All right, so let me go ahead and stop sharing here, because as you can see, we got plenty of time to do this image. So again, if anyone wants to say hi, ask a question about astronomy, the telescope, the astronomy club, don't ask me for financial advice because I'm poor. But so if anyone has any questions to fill the time, let's hear it. Well, sometimes you get a lively group, sometimes not so much. Uh, oh, okay. Someone anemometer. That's what you call the wind thing. I always forget that. I can never remember that. Anemometer. I think I'm saying that right. Oh, what does IC mean? IC is the index catalog. It's kind of a supplement to the new general catalog. And pretty much all the NGC objects and the IC objects, they were discovered by mainly William Herschel. Maybe some were discovered by John Herschel, and also some were discovered by Caroline Herschel. So Carolyn Herschel is the sister of the famous William Herschel, while John Herschel is the son of William Herschel. Carolyn Herschel never had children, but she lived to be like something like 96 years old, which was pretty impressive for her time period. Also very impressive because she was very sick at a young age, which is why she never grew more than like 5 feet tall. She was like 4'8" or something like that. How fast is the comet we saw traveling? Um, I could probably look it up, but it's receding from the sun now, so that means it's going to gradually slow down. But that one I don't know off the top of my head. If someone wants to look that up online, you could report that back to me. I got too many windows open now. I'll get confused if I open another one. And how often does the KS host online viewing sessions? We do them once a month from November to February. So this is the first one of the season, obviously. So after this, we have 3 more. We only do 4 of these because I figured any more than that, and they kind of wear out their welcome a bit. And plus, by the time we finally get into March, we start to get kind of clear skies here in Michigan. So it's much more fun to be outside as opposed to this. But from November to February, we really can't observe around here. So that's one of the reasons why we do online viewing sessions. Okay, we're gonna cut that guy's video off. There we go. And I can try to I can kind of hear someone talk there, but I haven't a clue what they're seeing. What is the bright source on the eastern horizon on the PE cam? I think I know what you're talking about there, but let's go back to the all sky camera because we're currently halfway into our exposure. So we'll go back to the camera here, and here we go. We'll check in with the all sky camera. So this is the east, and I'm not sure exactly what town this is. It's probably from some distant town in New Mexico, maybe Rodeo. That's my guess. Rodeo is probably one of the nearer towns to Portal, but it's also a very small town. But this light pollution you can see here is greatly exaggerated because this is roughly a 80-second exposure. So there are no significant light domes on the horizon.
Oh, there was like a car light or something. It's gone now in the latest image.
Okay. Yeah, we saw that really bright car pass near Mike's house earlier, or maybe that was somebody coming home.
Is that clouds on the horizon?
Yeah, I was worried that we were going to have clouds tonight, but it looks it's better than I thought, which is good. Because when we do delay these, we try to delay these by a week. We try not to do them on a Sunday because I know that's a bad day for a lot of people to do these. But this season, it works out to we can delay 1 week, but usually the attendance isn't very good. You can see, oh, there's a pesky cloud kind of going over Venus there. And Venus is about ready to drop behind the Chiricahua Mountains there, which is to the west. It's pretty flat to the north. And Mike Patton, are you here with us?
I'm with you.
What is this thing on the north?
I'll be honest with you, Richard. Tonight's the first time I've seen the all sky camera at night.
Okay.
I'd have to sit and figure that out. The bright light to the right, to the west.
Yeah.
I mean, I walk outside and it's dead dark all around this building.
Yeah.
So I don't know what that is. It's almost like something coming out of the all sky camera itself.
Yeah, we've seen this with the old camera. I don't know. So yeah, we were curious what this little thing here is.
To the north?
Yeah, it's right due north. I don't know what that little thing is. It's kind of
It might be
interesting.
my well house.
Okay, yeah, that's probably what it is.
Yeah, there's like 3 little dark spots, and
Yeah, I mean, it's appropriately positioned to be my well house.
Yeah. And this is Polaris, by the way. There's the 2 stars and the Little Dipper and the 4 stars in the bowl. We really couldn't see this too well before. We could just barely see Polaris on the old camera because, as I said, the old camera really cut off the north and the south. But now we can see the whole sky.
was this camera going for the Northern Lights last month?
We just barely. I don't think we had it quite running yet because we don't bring the remote telescope back online until October 1st. And I think we did get some stuff with the October 10th aurora, but not so much the other one. But we could see the comet on the all sky camera. I have an image saved that I could show to you where you could really see the comet noticeably, but now it's just way too small to see. I don't even quite know where exactly it is. It's probably getting too low to see now anyway. But
Hey, Richard,
yeah.
just on that view, that all sky view, just below the center, about halfway to the edge, that it looks like there's a perfect ellipse there of stars.
Down here?
One, two, right? Yeah. Go up
Here?
there. Yeah, that.
Oh, that's the head of Pisces. This is called the circlet, and it goes from out to here up to here. That's the constellation Pisces.
Oh,
Yep.
Hey, Richard, the thing that I identify as the well house, Jim thinks it's the weather station.
Oh, okay. Oh, we're almost done. Hopefully it's not too trailed. I'm so bummed we couldn't get a guide star. There are several. I'm looking at the remote computer, and there are so many stars in there that could be good guide stars. I don't know why I didn't pick any of them. Picky, picky, picky. Oh, wow. What are you going to do? Oh, yeah, it's not quite centered either. Huh. How odd. For some reason, the plate solving on the talk isn't working. Okay, so there's the thumbnail. But what happens is, of course, the camera downloads the image to the computer into a program called Maxim, which is what we use to control the main camera and the autoguider. And then Maxim does some automatic processing. The first thing it'll process is the thumbnail, but then it takes a little bit longer to upload the main image. Plus, it's doing like star counting. You can see it's 225 stars matched, so it is kind of working to a degree. Oh, there we go. So then we have to wait for this kind of to pop up here. And here we go. Are we ready for the next image? Go ahead, unmute yourself. I wish I had a drum roll.
ooh,
Whoa.
Ooh.
Wow.
Wow, nice, nice.
So it's a little trailed. Maybe I'll include a past image instead.
Wow.
So this is the elephant trunk here.
That is the elephant trunk.
Wow.
It's great. Nice.
So it's a little trail. Oh, and you can see more satellites. Oh man, they're just everywhere. They're just a freaking menace. Pardon my language. Okay, so IC 1396 is more than 100 light years across. The elephant's trunk itself, which again is right there, stretches over a region of 1 parsec, or not one, but I have a typo in my notes here, but it's about 40 light years long. Whatever that is in parsecs, it's more than one. And it's about 1.2 to 1.5 parsecs, or 4 to 5 light years wide at its widest.
Divide by 3.
Yeah, I know.
About 13.
Yeah, that sounds about right. So the star responsible for its glow is a binary and triple star system. I'll explain that in a minute, called HD 206 267. And I'm not quite sure which star it is. It could be one of the brighter ones in the center. Usually the most massive, brightest stars are in the center of the nebula. So what I mean by a binary and triple star system is that 2 stars orbit one another every 3.7 days. So 2 stars are very close together, while a third member lies further away, kind of like the Alpha Centauri system, because Alpha Centauri has Proxima Centauri, and just like with Proxima Centauri, the third companion in this triplet system could be just passing the double star by, because we're not really sure if Proxima Centauri is a true companion to Alpha Centauri. So HD 206 267, that kind of triplet star, is 15 arc minutes west. So I'm guessing that's this one, but if anyone knows for sure, feel free to chime in, because I don't know everything. So the elephant's trunk, or at least the whole region here of nebulosity, is a region of star formation containing more than 250 very young, less than 100,000 years old stars that were discovered in infrared images from Spitzer in 2003. And you can see at the very end of the elephant trunk here, which we designate as the end, is a little open region that you can call a hollow. It's kind of like an open cavity at the end of the trunk, and it's shaped by an F-type star that's about 13.3 in magnitude. It's not this one here for sure, but it's inside the hollow. So there we go. That's IC 1396, the elephant's trunk. And maybe with the download images, I'll include a better one from the past, because I don't know why we couldn't get a guide star on that one. So that's kind of that's kind of a bummer. All right, so let's go to our final target with the Takahashi. Everyone knows this one, I assume. M31. Make sure I hit get coordinates. And we'll do let's go ahead and do 3 minutes of this one. And we'll go to the luminance filter, and off we go. So yes, indeed, M31 is none other than the Andromeda Galaxy. And there are only a handful of objects that we do every season, because I try to circulate through images every season and add a few new ones here and there to keep it interesting. But M31, along with the Andromeda Galaxy, or not, that's the Andromeda Galaxy, along with the Orion Nebula and the Pleiades, we do those every season because they are awesome. So tonight is the night we're going to do M31, at least with the Takahashi. Sometimes we like to do close-ups with the big scope too. So it is one of the brightest galaxies in the sky at 3.44 magnitude. It is big, over 3 degrees across, and it's 2.5 million light years away. So it is big. And I didn't mention, I always include a sketch here from some amateur astronomer. I try to give credit where credit is due when I can. And so this is its appearance through very likely a dark sky site somewhere around the world. And so, this gives you a sense of what it can look like through a telescope. So I mentioned when we pointed out Andromeda and the all-sky camera, we were going to look at a little fuzzy just above Andromeda, and sure enough, it is M31, the Andromeda galaxy. So all you have to do to find this for yourself on the next clear night, and in Michigan, that could be a while, you just go from Alpheratz at the upper left corner of the Great Square here in Pegasus. Just kind of follow the first 2 stars in the arc, then go to the second 2 stars in the arc, and just kind of point toward the north, and you'll run right into it. You can't miss it. So here it is in a little greater detail with Sky-on Telescope's really handy pocket sky atlas. I highly recommend you get one. So it's located 1 degree west of New Andromeda, which is this star right there. The little Roman numeral V there is for New, NU. And Andromeda was first noted as a small cloud in the Book of Fixed Stars by the Persian astronomer Abd al-Rahman al-Sufi in the year 964 AD. The German astronomer Simon Marius was the first to describe M31 after observing it through a telescope in the year 1612. And even though we knew it wasn't a comet, Charles Messier included it in his catalog in 1764. If you don't know, Charles Messier made a list of objects like this that look like comets, but didn't move, so they were comet masqueraders, as he called them. But he well knew that the Andromeda Nebula, as they called it back then, was not a comet, but he just put it on his catalog anyway. And it is the nearest big galaxy to the Milky Way. There are several galaxies that are closer to the Milky Way, including the large and small Magellanic Clouds, but those are very small galaxies. The Andromeda galaxy, again, is the nearest big galaxy at 2.5 million light years away. So, along with the Milky Way, the Andromeda is one of the anchor galaxies of the local group of galaxies, which is a very poor galaxy cluster by galaxy cluster standards. It only has about 55 known members. There could be some newer ones I haven't heard about recently, but they're all very small if they do exist. So the local group of galaxies, again, it's about 55 galaxies and a kind of a irregularly shaped volume that's over about 1 million parsecs or 1 megaparsec in diameter. And so of the bright galaxies, 14 are dwarf ellipticals, which is why we consider those the most common type of galaxy in the universe. 3 are spiral, but really 4. We'll explain that. And then 4 are just kind of irregular in shape. So we know the Milky Way is a spiral galaxy. The Andromeda galaxy is a spiral galaxy. And probably next month, we'll check out M33. That's a spiral galaxy. But the 4th is most likely the Large Magellanic Cloud. It was classified once as an irregular galaxy, but if you really look at it in images, it has a barred spiral structure with kind of little short, stubby arms. So it is the 4th spiral galaxy in the local group of galaxies. And as you may have heard, the Milky Way and Andromeda are expected to merge, collide and merge in roughly 4 billion years. So there's the Milky Way. There's Andromeda with M33, the Triangulum galaxy. And people always say that M33 might get eaten by Andromeda first, but in every simulation I've ever seen, M33 always survives. So I don't know why people say that. So they're going to get closer and closer together, and boof, they pass right through each other. Stars don't collide because they're very far apart. On average, stars are, roughly 4 light years apart in a galaxy. But what does collide are dust and gas in the galaxy. So the two galaxies will undergo a massive burst of star formation before they ultimately collide into a supergiant elliptical galaxy. So there we go. And some people call this new galaxy far off in the future Milkomeda. Kind of a lame combination of Milky Way and Andromeda. Not my personal favorite. All right, so let's go ahead and go back to the ACP here, and we are guiding, and we're almost done. Oh, and Mohammed looked it up. Thanks, Mohammed. He says it's racing with a speed relative to Earth about 80.5 kilometers per second, or 180,000 miles per hour. Now, 180,000 miles per second, that's the speed of light, but the comet's moving much slower than that. And let's see. Yeah, I thought I mentioned earlier, yeah, that Jim's going to move the camera, the all-sky camera up later. What are the user bandwidth requirements for the remote telescope? Not very much. It does help to have high-speed internet, but DSL is really all you need because you can control everything with ACP right here. That's really all you need is a web browser to control the remote telescope. Oh, and the pointing didn't work again. Well, we're going to have to look into that while the pointing of the Takahashi is not working. I'm going to have to yell at Bob Denny, who's the creator of ACP. As many of you seen in past sessions, the pointing works just fine. I have all the aperture and focal lengths entered properly. Very strange. I know we've had issues with an update from ACP too. All right, here we go. Everyone ready for an off-kilter Andromeda galaxy? And 1, and a 2, and there we go.
Oh, my.
Wow.
Ooh,
Beautiful.
Very
Very nice.
Wow.
Come on.
Wow,
Beautiful.
looks good to me.
Beautiful. Mm-hmm. Beautiful.
Hang on there. I'm going to mute everyone again because we're picking up some background noises from people again. Just remember, those of you at home, we can hear everything you do when you are unmuted. So if you got to make a noise, please mute yourself. All right, so a few facts about the Andromeda Galaxy before we move on here. It is the largest, most massive galaxy in the local group. It's about 130,000 to 220,000 light years across. The bright portion of the galaxy is 130,000 light years across, but as you can kind of get a sense here, it does go further. So it could be as extensive as 220,000 light years across. It contains roughly 1 trillion stars. Compare that to 200 to 400 billion for the Milky Way. And it does have a mass of 1.5 trillion solar masses versus 850 billion solar masses for the Milky Way. But the Milky Way may contain more dark matter. It does have a supermassive black hole of 100 million solar masses, much more massive than our 4 million solar mass black hole. And you can see 2 of Andromeda's satellite galaxies. This is M32, which is a dwarf elliptical, as they both are. This is located 24 arc minutes south of M31's nucleus. It's about 6,000 light years across, contains 400 million stars, which makes it one of the densest known galaxies. It's very likely the nucleus of a now absorbed galaxy, except for the center of the galaxy. But the disk has been ripped away from this now kind of naked nucleus. And it may contain a supermassive black hole of about 2.5 million solar masses. And down here is M110, the last entry in the Messier catalog. It's also known as NGC 205. It contains about 10 billion stars and is 16,000 light years across. And there is no evidence for a supermassive black hole. It could have, maybe an intermediate mass black hole, but we haven't even detected evidence for that yet. So that's kind of unusual, because quite often you find those supermassive black holes in galaxies. So there we go. Again, we're not quite centering in the Takahashi for some reason. We'll have to investigate that. But there we go. That's our last target with the Takahashi tonight. All right. So before we move on here, we're going to switch to the 20-inch now. I have to go into the remote computer and change the information for the telescope for the big one, because ACP can only accommodate one telescope at a time. That's kind of one of its down turned qualities. Here we go. Because I often forget to do this if you've attended before, and that can cause problems. Okay, so now I'm going to scroll down here, and somewhere here it is, and switch to the switch to the big scope. So let me keep it here. I'm going to turn this on here. And oh, we just caught it. The flip flap on the Takahashi just closed. So we're putting the Takahashi to sleep. And now we're going to fire up the camera to the big scope here. So that'll take just a few minutes or so. So while we're waiting, we'll introduce you to our target. So yes, now we're going to switch to the main event telescope here, our Planewave CDK20. So this is a 20-inch corrected dull Kirkham telescope. That's what CDK stands for. So a dull Kirkham means it has an ellipsoidal primary mirror and a spherical secondary mirror. You can't quite see the secondary here, but then there's a little corrective lens group in the back here. So that's what the corrected part comes from. And yes, it does have a 20-inch mirror and a pretty short focal length for its size, 3,454 millimeters. And on the back of the telescope is our imaging train. We use the same camera that we use on the Takahashi, at least for now, that has caused some issues in the past, most of which I think we have resolved now. But having two of the same camera on the same system has been a little problematic over the years. And we might eventually remove the on-axis guider here, because all the guiding, either with the 20-inch or the Takahashi, is done through the 20-inch. And it's been kind of hit and miss with the on-axis guider. So I haven't been really 100% happy with the performance. So I think we're going to remove this, and we're probably going to try just a separate guide scope for the time being. I know that can have its issues, but I think it'll be a lot more reliable for the way we control the telescope here, because we don't have rotators for off-axis guiders and all that sort of thing. And you can see our guiding camera here and all that. So both telescopes are supported by our software BISC Paramount ME2. This mount is similar in capability to the mount we have in Owl Observatory, which is an astrophysics 1600. But this one holds about 20 pounds more at 240 pounds. And it is very accurate, even though, you notice the pointing of the Takahashi, wasn't working terribly well, but the object was always in there, and that's because of the accuracy of the Paramount. But if the plate solving was working correctly, objects in the Takahashi would have been centered, except for the comet. That would have been off kilter either way. And it's a highly capable mount. All right, let's go back and see how we're doing here. We should be done by now. Whoops. Of course, you can't tell if the 20-inch is ready, but there we go. It's ready. Okay. So while we're here, I'm going to type in our next target. We haven't done this one in quite a while, so I figured, what the heck, let's go ahead and do it. It's getting a little low, but that's okay. All right, off it goes. All right, so our first target with the 20-inch is a very popular target every summer at observing sessions like ours. It is M27, the Dumbbell Nebula. And as many people know, that is not my favorite name because my last name is Bell, and so I don't think the word dumb and bell should be combined together. That just seems insulting to me. and plus, whenever I show people the Dumbbell Nebula, they're like, I don't see a dumbbell. But if I tell them to look for the apple core, they see it right away. So I really think M27 should be better known as the Apple Core Nebula. That is another name for it, but of course, the Dumbbell Nebula is very prevalent. But the name comes from John Herschel in 1833, the son of William Herschel, who described it as a nebula shaped like a dumbbell, with the elliptic outline completed by a feeble nebulous light. This was the first planetary nebula ever discovered. So it is a planetary nebula. And it was discovered by Charles Messier on July 12th, 1764, and became one of the entries in his famous catalog. William Herschel was the first to designate M27 as a planetary nebula around the year 1784. And there are 3 other Messier planetary nebulae. Can anyone name them? Somebody name one, the first one, the most famous one. Come on, there are 3 others. I know a lot of you out there know it. What's the most famous planetary nebula, probably? Next to the dumbbell, or maybe even greater than the Dumbbell Nebula.
Orion
Ring
Nebula.
Nebula.
I think I heard it overlap. The Orion Nebula is an emission nebula, but M57 is the Ring Nebula, which is probably, in my view, the more famous of the two. Even though the Dumbbell Nebula is larger, but M57 has a much more distinct shape. So there's 2, M27, M57. Anyone know the other 2? There's M76. That's the Little Dumbbell Nebula. And then
the owl?
Right. M97 is the Owl Nebula. So those are the only 4 planetary nebulae in the Messier catalog. It is the second brightest planetary nebula in the sky at about 7.5 magnitude. It's second only to the Helix Nebula in Aquarius, but the Helix Nebula is about the size of the full moon, so its surface brightness is much lower. So between this and the Ring Nebula, they're 2 of the easiest to find and observe planetary nebulae in the entire sky. And yeah, it's a whopping 1,227 light years away. This is its general position. It is getting very low right now because it is inside the summer triangle of Vega, Deneb, and Altair. It's technically in the constellation Vulpecula, the fox, right between kind of the edge of Vulpecula and the tip of the arrow in Sagitta. So it's not quite as easy to find as the Ring Nebula, which is like right between these 2 stars here, but it is pretty easy to track down your first time with binoculars or a telescope. And more specifically, here's its location on the Pocket Sky Atlas. So this is the end of Vulpecula and the tip of the arrow in Sagitta. So it's about 3 degrees north of Gamma Sagitta here, or 2 degrees southeast of 14 Vulpeculae. I don't know why I say 14. I should say 13. I'm not even sure where 14 is. Where is 14? I'll fix that in my notes later. and this little feature here, this is the constellation Delphinus. Oh, our image is done. So let me explain this real quick. What a planetary nebula is this is the end stage for all medium mass stars, which includes the sun. So all stars at one time or another, they fuse hydrogen into helium in their core. But there's only so much hydrogen in the core to fuse. So when hydrogen fusion ends, fusion in the core of the star ceases. So the core of the star begin to be taken over by gravity. The core gets denser and hotter. So gravity crushes it to a smaller, denser, hotter state. But while this happens, the star itself contracts a bit. And in a layer just outside the core, hydrogen begins to fuse. So as we saw here, let me run that again. I should have that on repeat. The star expands into a red giant. Every time the star expands, it ejects a layer into space, as seen here. And so eventually, the core gets hot enough at 100 million Kelvin to ignite helium fusion. So that makes the star contract a bit. But eventually, the star will run out of helium and it'll expand again. And so the star goes through these stages of expansion and contraction. And every time it expands, it ejects layers into space, as you saw in that video. Then eventually, the star, the star's layers are all expelled into space except for the core. And the dense core, which is usually composed of carbon-oxygen atoms because all the helium has been used up, becomes what's called a white dwarf. Now, white dwarfs are really extreme. They're usually around 150,000 Kelvin in temperature, extremely hot. But they're only about the size of the Earth. And they usually have around half or upwards of toward the mass of the sun. So they're like something the mass of the sun, but the size of the Earth. So they are incredibly dense. So that's what we find at the center of most planetary nebulae. And they're so hot, they give off ultraviolet radiation, and they cause, let me back up here, they cause the gas that was ejected to glow. And that's what we see as a planetary nebula. Now, they're called planetary nebula because at low magnifications, they look like planets. But other than that, they have nothing to do with planets. And our image is done here. So let's go back to oh no, we're not done yet. I thought we were done. Oh, what I saw was the plate solving image. So I'm glad I didn't waste any time. So we're about a little more than halfway through. So just to finish my example here, if you could scoop up like a sugar cube size of material from a white dwarf, it would weigh about 50 tons. So they are incredibly dense objects, and they slowly cool off over time, and eventually a white dwarf will become a black dwarf. But if we ever find one, we're in big trouble because the universe isn't old enough for black dwarfs to exist yet, because it hasn't been around long enough, for a white dwarf to cool off fully. The coolest white dwarfs are about the temperature of the sun, so they actually look yellow, but we still call them white dwarfs. We named these things before we fully understood them. And when white dwarfs are new, when they're brand new and very hot, they actually look blue. But as they cool off a bit, they will look white. But we always call them white dwarfs. I don't know exactly why we stuck with white. So we're almost done there. And we didn't get a guide star again. It must be high clouds. Let's look at the all-sky camera. Whoops, not that one. That's odd. We didn't get a guide star. It is getting low too, but there must be thin clouds that are blocking the view. Because the on-axis guider guides in the infrared. So thin clouds can really wreak havoc on the infrared. So that's probably why we're not getting another guide star. Well, poop. Oh well. Another reason why we're going to scrap the on-axis guider. It just hasn't worked out. Huh. Oh, there it is. It's right in the center though. So the plate solving is working and just didn't get a guide star, which, why wouldn't it get a guide star? There's lots of stars around here. All right, so it's going to count stars. 23,370 image stars found. But that's a lot. Let's count them. It's still working. Okay, come on. All right, we're done. All right, everyone ready? Go ahead and unmute yourself. It's time for the unveiling.
Ooh, wow, what an apple.
You're done.
Stars are looking big too for some reason. I did focus the telescope. It must be thin clouds that are making the stars look all puffy like this. That is weird. So that's not the best image ever, but that's pretty good. There
Great
it is.
image.
Looks out of focus. But I did focus the telescope before the session, and it doesn't change that fast. Oh well. So when observed from Earth, M27 appears along its equatorial plane. If we could view it at like a 90-degree different angle, it would probably look very much like the Ring Nebula. It has an estimated age of 9,800 to 14,600 years old. These objects tend not to last longer than roughly 25,000 years because as they expand, the gas, recedes away from the white dwarf at the center, which is the source of illumination for this nebula. So it'll just get lost in the interstellar medium and eventually become recycled to a next generation of stars. Now, you can't see them in this image because you have to have like the Hubble Space Telescope to do it. M27 hosts many knots of gas and dust that range from 11 to 35 billion miles across. Each contains about as much mass as 3 Earths. So check out an image of M27 from the Hubble Space Telescope. I'm not sure if the Webb telescope has imaged this yet. It probably has. So the dumbbell shell of gas is expanding at a rate of 17 miles per hour or 31 kilometers a second. So that's a hell of a lot faster than the comet is receding from the sun. The temperature of the white dwarf is 153,000 degrees Fahrenheit or 85,000 degrees Kelvin. For reference, the surface of the sun is 5,800 Kelvin. And it does have a 17th magnitude companion separated by about 6.5 arc seconds, which works out to 2,500 AU. And that was discovered in 1970. It does have a larger diameter than most other white dwarfs. It's about 6 times the Earth's diameter. So that's pretty big for a white dwarf. Again, usually they're about the size of the Earth. but it does have a mass estimated to be about 0.56 solar masses. So that's pretty low mass for such a big size. So I'm not quite sure what the discrepancy there is. Now, if it were 1.4 solar masses, that would be bad because white dwarfs cannot be more massive than 1.4 solar masses. Otherwise, they blow up as a type 1a supernova. So it has no chance of doing that, though. Even if it absorbs its companion, it'll probably never get close enough to that. So there we go. Kind of a fuzzy image of the Dumbbell Nebula. I'm tempted to focus the telescope real quick, but I'm not sure I want to take time to do it. Okay, our next target. Boy, it would really be better if it were focused. Let me go ahead and try to focus the telescope real quick. We can. It shouldn't take too long. It might have to home the focuser though, and that's what I don't want to do, because that takes forever. I've never had to focus the telescope during a session before. Usually I focus right before and it's just fine, but tonight for some reason it is not. Yeah, it's going to home the focuser, so that's going to take forever. So we're just going to have to bag it. Let me hit the kill switch here, because it's going to take a good 5 minutes to focus this thing, and I don't want to keep you folks waiting that long. So they're going to be a little fuzzy here, I think. Oh, I can't kill it while it's homing the focuser. Oh no! Well, I guess we're stuck. So let me go ahead and stop sharing there. I'm going to let it run in the background, and because globular clusters, they require good focus to see anything. It's going to look terrible if it's out of focus, and it has to rehome the focuser because I switched from the plane wave to the Takahashi. So it's starting all over again. And again, that is so odd. It's so out of focus. So that's going to take its sweet time. Let's do a live view of the observatory. Oh, I forgot to turn the infrared camera off too. Well, that's bad. We're kind of pointing away from it though, so it didn't seem to affect it too much. And the clouds are becoming a little more prevalent, not too bad. Our next target is going to be down here somewhere. Right behind the bird perch is the constellation Capricornus. And we're going to look right around here. That could be it right there, in fact. I'm not sure. It looks too sharp, though. So that's kind of a hint. And you can see that Jupiter in Taurus has gotten higher. You can really see the Hyades and the Pleiades a lot better. It's still homing. It takes so long to home the focuser, but it'll be worth the wait.
Much better than my all sky camera showing clouds.
Oh, I bet. Oh, and I didn't notice earlier, but now you can see the 3 stars in Orion's belt. There's Betelgeuse and Bellatrix and Rigel. So Orion is rising. A sure tail sign that winter is on the way. You can't stop it. We're supposed to get more winter this week. Boo. Oh, shoot. Okay. Oh, right. I interrupted the script. Yeah, I guess we waited this long. I might as well go ahead and try to run the focus again. But now I gotta. The good news is I don't have to. The focuser won't have to home itself again, because now it knows where it is. All right, now it's going to ask me what filter I want to do. We're going to do the luminance filter. I can't tell you how many sessions we've done where I never have to focus again. It's usually pretty good. When I'm imaging, I always focus every hour, but that's for high quality images. For this, you don't have to focus that often, but for some reason, the focus has slipped out of place. Very strange. Let me, I'm going to close the connection to the computer on this other laptop here. Let me open it on my laptop and you guys can see what's going on here. There we go. Let me, whoa. Rearrange the screen here real quick. That's good enough. It's being laggy. Okay, so here we go. That's the one I want. All right, so you should be able to see it now. This is the screen of the remote computer in PEC Observatory. And you can see it selected, this is the preview field here, which we don't need anymore. We can make that go away. And this is the star that it has automatically selected to focus. And we use a program called Focus Max to focus both telescopes. But of course, right now it's only focusing the 20-inch. It's doing 4-second exposures. And every time it does, it changes the focus a little bit. So you can see it's the current position is here. It moves it to this position here. So this will change to 60,244 as it tweaks the focus a bit. And once you home the focuser, which we waited for, it goes pretty fast. Unfortunately, the wind is very light tonight. If you have attended past online viewing sessions, sometimes the wind can be a problem. The wind has caused us to postpone. I wish we could say we have a perfect record, but in the first 2 sessions in 2022, they had the really unusual heavy rain in California, and that spilled over as clouds in Arizona. And so we got clouded out for both the primary and cloud date sessions in both November and December for the first time ever. Otherwise, we would have a perfect record. But the weather was really strange that year. $73,000. Well, that seems really higher than usual. Huh. Oh, I hate it when it gongs in my ear. It's done. Okay. Let me go back. Here, I'll do it so everyone can see what I'm doing. And it completed successfully. Yay. And now we'll scroll down here to our single image acquisition screen. And we're going to type in M30. We'll see how our focus did. I'll go ahead and keep it. Now let's do 180. Don't want to overblow the core or anything. And here we go. Okay. So yes, indeed, our next target is M30. It doesn't really have a common popular name, but I call it the Capricornus cluster because it's the most prominent cluster in Capricornus. So why not? Why not call it the Capricornus cluster? That's what I call it. So it's basically a very nice globular cluster. Very similar distance to M13. M13, probably the most famous globular cluster in the northern sky. That's about 26,000 light years away. So M30 is 27,140 light years away. And there's a sketch. Doesn't quite reveal how grand it is, though. And it is just, what direction is that? East of Capricornus. Capricornus is the half goat, half fish creature, but looks like a big Cheshire cat smile. So it's just to the edge of that. And it's located about 23 arc minutes west-northwest of the 5.21 magnitude binary star 41 Capricorni, which I cover up here a bit. But there it is right there. Or about 3 1/3 degrees east-southeast of Zeta Capricorni, which is right there. That's the Greek letter for Zeta. It was discovered by Charles Messier on August 3rd, 1764. He described it as a nebula and noted it can be seen with difficulty in a simple refractor of 3.5 feet. They always referred to the refractors by focal length back then. And it is round and does not contain any star. Boy, was he wrong. So William Herschel observed M30 in 1783 and wrote in his personal notes, a brilliant cluster, the stars of which are gradually more compressed in the middle. The figure is irregularly round. The stars are about center and so much compressed as to appear to run together. Pretty good description of a globular cluster. So it is visually seen to have a lopsided appearance, with the northern portion displays well-defined fingers of stars, while the southern part looks needed but incomplete. So we'll see if that comes about in the images that we can see here. All right, let's see how we're doing there. We should have time. I see we got some more questions. We should have time to answer those. We'll only check on our progress here. It's working. Oh, I gotta turn off the camera too. Eek. Okay, camera's off. We don't want the camera on. Whoops. Okay, it's just working in the background. It's still doing its thing. I believe it's just slewing. So we'll just let it run there. So in the chat here, we have, is it possible to put up a full sky camera at our home? Yes, it is. You can ask Pete Mumbauer for advice on that. Pete Mumbauer has an all-sky camera in his backyard. He lives down near Schoolcraft in Vicksburg. I've been trying to get him to see if we can put that on the website. Of course, right now it wouldn't look like much because it's typical Michigan weather. So what are your opinions for the best start in visual astronomy? Yep, it would be good to get a pair of 7x50 if you're younger, or 10x50 binoculars if you're older, usually 50 and up, 10x50. Younger than that, you can do 7x50. I have a huge lecture on binoculars on our YouTube channel called Binocular Basics. You can look for that there. Oh, and I was going to ask, how many folks found out about the session? And there's no guide stars again. It's got to be the cloud. There must be thin clouds. Oh, poop. Well, we're only doing 3 minutes, so that's not too bad. We can do 3 minutes. But there ain't squat for guide stars in there. Let's go. I think we're still on the ACP, right? Because I'm switching around here. Okay, so we're doing another unguided exposure. This does happen to us a lot when we have thin clouds coming in. And again, it's worse in the infrared than it is invisible. But 3 minutes unguided shouldn't be too bad with the Paramount. It's pretty accurate. Oh, Pete, you have a website?
I need to pick your brain about website development.
Okay.
But yeah, something basic.
Oh, we'll have to take a look at it later.
Yep.
I'll link it from my website if I can ever get the damn thing done. Let's go ahead and stop sharing for a few minutes there. So I think I got all the questions here. If I missed your question, just go ahead and ask me out loud. I'm looking at like 4 different screens here continuously, so sometimes it's a little hard to go through the chat. It's easier to hear you ask them than put it in the chat. So if I missed your question, just ask me verbally. Well, let's while we're waiting, let's go back and check the all sky camera again. Oh, that's not it. I always click on that one. The clouds are staying low, so that's good. They're not really drifting across the sky. They sure were earlier today. Most of the day it's been very, very sunny, but then kind of late in the day, the thin clouds from the west started moving in. And M30 is low too. So, but I wanted to do a globular cluster. I try not to do like all clusters or all nebulae or all galaxies. I try to mix it up a little bit.
Did you say the old all sky cam got that light arc on the right?
I think so, yeah. This camera is much more sensitive, so it looks a lot brighter than it did before. And it could be from the infrared camera in there. We do have the other webcam. We should probably just shut that down when we don't need it.
Yeah, the last frame I saw a little reflection on the bird perch. So who knows?
Yeah. What filters are in your filter wheels? Well, we have a luminance filter. Oh, here we go. We have a red, green, blue filter, and we have hydrogen alpha, oxygen 3, and sulfur 2. All right, everyone ready for M30? Here we go. Doesn't look too bad. Oh, it's not done yet. It's still counting stars. Oh, now it's done. You can hear the gonk in my ear. I hate that. All right, here we go. And a little fuzzy.
Oh,
Still very nice. Very nice, Richard.
Very
very
nice.
clear. Oh, it looks like a crown right there.
Yeah, boy, even with the focus, it's looking fuzzy. It's got to be the sky conditions. Very strange. All right, here we go. And a little fuzzy.
Oh,
Yeah,
Still very nice. Very nice.
it is.
clear. Oh, it looks like a.
Well, probably when you download the images later, I think I'll cheat and use better ones from the past. Because I do not know why these are turning out so fuzzy. It is very odd. All right, just a few quick facts here, then we'll move on. So the true physical size of M30 is about 93 light years. It's about 12.93 billion years old. Better ones from the past. Oh, Could everyone please
I don't
mute?
know why these are turning out so fuzzy.
It's Becky who's showing that.
Okay,
Mute her.
I'm gonna mute everybody. Okay. Where was I? Okay, so it has a total mass of about 160,000 solar masses. It's very low in metallicity, only 1/100th as metal rich as the sun. So that's pretty typical for globular clusters, because at 13 billion years old, this thing formed when the universe was pretty much nothing but hydrogen and helium. So the stars have a much higher content of hydrogen and helium than the sun does. And the sun has more heavy elements, basically everything but hydrogen and helium, because the heavier stuff besides hydrogen and helium, those came from supernovae. So when the universe was really young, there weren't very many stars that went supernova yet. So they could only form from hydrogen and helium. So it's a very metal poor object. And this does orbit the galactic center, as all objects do, at an inclination of 50 degrees below the galactic plane. Takes about 160 million years to complete one orbit about the galactic center, which is actually shorter than the time it takes the sun to go once around the galaxy at roughly 240 million years. So its incline makes its distance from the galactic center vary by 10,000 to 25,000 light years. It follows a retrograde orbit, opposite most other globular clusters through the inner halo, suggesting that it was captured from a dwarf satellite galaxy. The core stars are very densely packed, showing it has suffered a core collapse. Has 1 million stars per cubic parsec, so they are really packed there in the center. It does contain an unusual number of blue stragglers, merging of two stars by mass transfer in a close binary system, which does give the core a bluish color. But obviously, we're not going to take the time to do a color image tonight, because that would take a long time. So there we go, another fuzzy M30 for some strange reason. I don't know why we're getting so many fuzzy targets here tonight. So that's kind of a bummer. All right, so for our last one here, I think that updated. Let me hit it again, just make sure. Oh, no, I didn't. Okay. We're going to do 5 minutes this time. And we're going to go ahead and hit acquire image and let it run. So our final target of the night is M74, the Phantom Galaxy. That name actually comes from Stephen James O'Meara. He used to be with Sky and Telescope. I believe he's still with Astronomy Magazine, but he might not be any longer. And he's well known for his visual observation skills. And he's written many books, and I have quite a few of them. So out of any author ever, I think I have more books by Stephen James O'Meara than anybody. This galaxy was discovered by Pierre Méchain, who was Messier's assistant in late 1780, September 1780. And actually, Méchain found 24 or 25 objects in the Messier catalog, and also NGC 5195, which is the companion galaxy to M51, the Whirlpool galaxy. It does have a low surface brightness, making it the most difficult Messier object to observe visually, because it is pretty good size for a galaxy, and we see it face on, so its surface brightness is quite low. And Méchain noted this nebula is quite broad, very dim, and extremely difficult to observe. It may be distinguished more accurately during fine frosts. Of course, what he meant by that is when it is very cold, the sky can be very dry and very transparent. So here's its general location in Pisces, and someone noted the circlet earlier. I don't have it labeled on this diagram, but this is the circlet I pointed out on the all-sky camera earlier, right below the Great Square in Pegasus. And it's basically like two fish tied together in a ribbon. That's what Pisces is supposed to look like. So M74 is just outside the line of the other side of the other fish, I guess you could say. So that's its general position in the sky. Here it is a little more specifically on the Sky and Telescope Pocket Sky Atlas. So it's located about 1½ degree east-northeast of Eta Piscium, or Kelet Nunu. So there it is right there. Kelet Nunu. I think I'm saying that right. Who knows? All right, let's go back to ACP, see how we're doing. It's still working. And I can't check on the status because I closed that on the other computer. So I'm going to close it on this computer. Oh, well, maybe not so much. I believe it's still, yeah, it must still be slewing. Let's see if we can get a quick view of that. Oops. We'll turn it on there real quick. We should be looking kind of high. Oh, it's still slewing. So that's nice. We can watch it slew. We don't do that terribly often. So it's going to have to spin all the way around and kind of point somewhat high in the south. So going to the all-sky camera, there's the circlet. That's where I always start from to find Pisces. Then just kind of work your way down this chain of stars here and go up a bit, and it's right around here somewhere. Obviously, you can't see it. It's pretty faint. But it's right around this part of the sky. So it's pretty high. A little more, definitely more than halfway up, maybe a good 70 degrees or so. It'll say up here eventually. It'll post the altitude update here later. And there it goes. It's swinging all the way around.
I hope those counterweights don't hit anyone.
No. I know we need to reorganize the counterweights. The really heavy one should be on the center, but we'll work on that. Oh, looks like we're all done.
How much weight is there?
I think the big one is 50 and the others are 30. I think there's like 6 of those. So quite a bit. It's like 250, something like that. I'm working too fast here to do math. Even simple math. 180, 230, I guess. Okay, so you can see we're doing a pointing update. It's doing its pointing thing. It does a plate solve, and then it'll precisely center the target. And that is working on the 20-inch. For some reason, it's not working with the Takahashi. And I don't know why. And here we can switch to the Piishi. And there's our poor selection of guide stars. And it did find one. Yay. Now let's see if it likes it. Our luck isn't too great tonight, so it might not even like the guide star. But if all goes well, it'll say guiding settling or settle guiding or something like that, which means it's about ready to start guiding. But it goes through certain settings to see which ones work best. And I do notice the focus settled on about 52,500. I don't know why it shot up to 70,000 earlier. That's crazy. Looks good. And look, it's 25% humidity. That's just disgusting. Oh, guider settle. So it's starting to guide. So we can go back to ACP and see what that looks like from there. There we go.
Do you know what the population of Porto is?
It's about 100.
Wow.
And yeah, the gutting looks a little rough tonight. Yeah, it's not the best night for imaging. You got some kind of system coming in with those clouds. So that's causing all kinds of havoc with us tonight, I think. Does anyone remember Roger McPherson? I did meet Roger a handful of times. We did get him to come back to a meeting when we showed the Paramount for the remote telescope the first time. But he dropped out of the club pretty early in the 70s, I think. He was not a member throughout the 80s and 90s, but you know he ran a business and up in Otsego and all that, so he was pretty busy. He did pass away a few years ago. You're welcome. So we're guiding. Can't see anything. I'm always hoping we pick up a bright meteor. Let's reload. We've gotten meteors, but never any really bright ones. Need like a Chelyabinsk meteor, like the big one in Russia that exploded. That would leave like a big bright blur across the sky. That would be awesome. We would sell prints of that for like $10,000. Oh, and here's another constellation. You can see Cetus. This is like his head. And it goes back up to these stars here. To me, it looks like a vacuum cleaner instead of a sea monster. But this is Cetus here. Cetus, so if I ever start a vacuum cleaner company, I'll call it Cetus because Cetus looks like a vacuum cleaner. That's just me.
Looks like you can see the double cluster right overhead.
Oh yeah, there it is. I thought about doing that tonight too. I'm kind of glad I didn't with the focuser all out of whack for some reason.
Oh, probably the Takahashi.
Yeah, I would use the Takahashi. It's too big for the 20-inch. You can get both clusters in there, but barely, or not totally, I should say. Yeah, you cut off one or the other.
Yeah, this is a great all sky camera. Really sensitive.
It is. It's great. And you can see Orion's higher. You can see safe now. So Orion has completely risen. And as Robert Frost said, Orion always comes up sideways. And sure enough, it does. Although it looks right side up on the all sky camera. You can see his shield. And of course, his sword with the Orion Nebula and his little tiny head. And here's Auriga, the charioteer, with the bright star Capella. So we're getting some of the stars of the winter hexagon. Oh, and we do a reload.
Is that Saturn like above the bird perch?
Oh, yeah. Oh, yep. Yep, there's Saturn right there. That's got to be it. And no, we cannot do planets with the remote telescope. It wasn't designed for that. It's a deep sky telescope. Even at 3,454 millimeter focal length, that is too short to really do the planets justice. And now the comet has long set. At least we got one good peek at it. Maybe next month we can look at it with the 20-inch. I'm not sure how high or low it's going to be for the next session in December. And darn it, if it wasn't for the focus issue, I would have finished up right on time here. So we're going to go a little overtime here tonight. I don't get paid extra, though. That's just totally not fair.
What's the temperature there right now? I mean, 36% for minus 20 is pretty good.
It's the ambient temperature is 56.8 degrees. All right. And don't ask me why the program here shows it going 5 seconds over. It doesn't actually do that in reality, but for some reason that shows up like that on ACP. Don't ask me why. All right, there it is, right in the center. Now we have to wait for it to count stars and all that sort of thing. I don't know why it has to do that at the end. I mean, who cares? We want to see the picture. Computer is running a little slow. We need to upgrade the computer too, because we use Windows 10. And all right, it's all done. Everyone ready for the last image of the night? Here we go. Oh, that looks better. That's not too bad.
Very nice.
Very good.
Very good.
Very
Mhm.
nice.
Yeah, that's
Cool.
outstanding.
Very
Okay.
nice.
Which one?
That's pretty good.
This time the focus looks good. My guess is we're looking too low, and the scene tonight is terrible. That explains the guiding issues earlier too. So yeah, the scene is just rotten, and the transparency is down toward the horizon with those clouds coming in, because that's pretty focused. All right, so M74 is the archetypal example of a grand design spiral galaxy, which means it has two pretty symmetrical spiral arms, but I've seen better examples of grand design spiral galaxies, like M81 is much more uniform in my opinion. It's about 95,000 light years in diameter and contains at least 100 billion stars. So a little smaller, fewer stars than the Milky Way. M74 is gravitationally the gravitational center of a small galaxy group including the barred spiral NGC 660, along with many other UGC galaxies I won't bother to mention. And to date, there have been 3 supernovae in this galaxy, one of which may have been a hypernova. The Chandra X-ray Observatory may have found an intermediate mass black hole of 10,000 solar masses. So there are black holes, from collapsed stars. Those are usually between 3 and maybe 100 solar masses. But then you go to the supermassive black holes in the hearts of galaxies that are usually millions or billions of solar masses. So a lot of astronomers think there are intermediate mass black holes in many globular clusters, and in this case, at least one pretty big galaxy. So a galaxy this big with such a tiny black hole is pretty unusual. Even the Milky Way's black hole is small by comparison. So there we go. So let me wrap things up here. Wish it would switch for me. So, of course, if you are currently a member of the Kalamazoo Astronomical Society or want to be a member and live in one of these counties, you can join the club, pay the remote telescope fee, watch a video, read the user manual, and you too can use the remote telescope all on your own. But you do have to live in one of these counties, because if we opened it up to everyone, it would be terrible. It is not a commercial product. We do our best to maintain it. It usually works pretty reliably, but we don't want to open it up to people around the world. That's just too much pressure for volunteers. It is a lot cheaper than a commercial remote telescope. So be sure to join us for our next online viewing session. It is on December 21st with a cloud date of December 28th. And let me see if I can put in a couple of links in here for you. I'm going to put 3 of them in there at once. I'm just going to put them all in. That'll save a little bit of time here. Sometimes I have a co-host, but I didn't really seek out a co-host and no one volunteered. So I'm going to put a bunch of stuff in the chat here. There we go. So, of course, there's a link in there to join the Kalamazoo Astronomical Society. We are the oldest and the largest club in Michigan. In fact, right now, no astronomy club in the history of Michigan has been as big as we are. We have over 500 individual members, which is pretty good for a little tiny town in Southwest Michigan, which I think shows just how freaking awesome we are. So we are a pretty good group to join. So I do have a registration link in there for the December 21st session, but if you are a KAS member or you are on the online viewing session email list, you can receive updates if you forget to register tonight. So there are many ways you can join the online viewing session email list. If you have your phone or tablet handy, you can scan this QR code and it'll take you to a website. I do have a link to the website in the chat as well, and you can join the online viewing session email list directly. If you are a member, you do not need to join the online viewing session email list though. But if you forget, you can always use our contact form on our website or use this email address and I will add you personally. But now you can add yourself directly to our mailing list on MailChimp. So this is a ways off, but I thought I would mention it because it's a pretty cool speaker. J. Richard Gott is a very well-known astrophysicist from Princeton University, quite famous in fact. And he's going to be joining us via Zoom on Friday, January 10th at 7 o'clock p.m. You can join us in person at the Kalamazoo Area Math and Science Center, or if you do not live in the Kalamazoo area, you can join us right here on Zoom. It will eventually be available on YouTube as well, but I get pretty delayed in putting stuff on YouTube these days, on purpose too, by the way, just FYI. And finally, here is the link to download the images. Obviously, they are not there right now because I got to download them myself. I got to process them, and then I will post them. So I'll probably get those up, maybe late tonight if I feel like it, but most likely Sunday and no later than Monday, I promise. So if it's Tuesday, go ahead and email me and say, hey, where are the images? But please don't email me and ask until Tuesday. I'm only human, folks. Give me a break. And I got to work on our newsletter too. So I got plenty to do. But I will get those images on as soon as possible. And I do have a link for that in the chat as well, but just be sure to copy it and save it. But if you are a member or you're on the online viewing session email list, you have this link already. So there you go. And of course, the images that you will download will be full resolution. So you can zoom in a lot closer than you could here tonight. And I think I will probably substitute a couple of images from past sessions that look a little bit better than what we acquired here tonight. Because again, the conditions are obviously pretty poor out there tonight. I'm pretty sure now that it is the seeing conditions out there. They are pretty terrible. So that concludes the first observing session of the season. And thanks again for joining us. We'll see you next time.